Okay. Good morning, grade 7. Can you all hear me? Can you hear me well? Okay, so today we are going to continue with what we have studied last week about the electric current and the resistance and the function of the resistance in the electric circuit. And before that, I have just to tell you that the quiz is available now on the school's website. I don't know if some of you have been tried to solve this quiz or not, but the quiz is available now. Okay, you can go and check it after this session. Okay, and about today we are going to talk about two kind of circuit, okay, or two kind of connection and circuit. One of them is series and the other is parallel, okay? So we have studied last week the function, the importance of the resistance inside our electric circuit. How can we use resistance? Why we use resistance? What we mean first by resistance, and what are the different types of resistance, okay? So we have studied the resistor, the fuse, okay? And we have seen many function of this kind of resistance inside our electric circuit, okay? And today we are going to talk about something related to what we have said in earlier sessions, okay? And our session today will be about series and parallel connection inside the circuit, okay? So what we mean by series, what we mean by parallel, okay? So series means you are connecting, or first of all, the objective of this lesson is to understand the difference between series and parallel, okay? And first, we want to know what we mean by series and what we mean by parallel circuit, okay? So in our electric circuit, we have studied that electric circuit consisted of battery, switch, and wires, okay? And electrons move through this kind of circuit, okay? And current in addition to that, okay? So we have seen, in addition to lamp, which an indication to the electric current inside our circuit, okay? So we have seen the basic constituent for the circuit, okay? But we have two circuits to think about, okay? So when we are talking about any circuit, okay, in any electric device, we are talking about two kinds of circuits, okay? One of them is series circuit, and the other is parallel circuit, okay? So what we mean by them, and what is the difference between them? So first, what we mean by series circuit, okay? So as you can see here, okay, you have two things here are connected directly with each other, okay? And the line between them, you have only one line, okay? You have only one line here. This is the line connect them with each other. You have only one line that connect them directly, okay? So they don't have any bypass, okay? They don't have any kind of bypass or by connection, okay? So they are connected with each other directly, okay? So when you have this kind of circuit that the parts of the circuit are connected directly with each other without having any kind of no bypass, okay, that connect them, we call this series circuit, okay? So what we mean by this is series, okay? So when you have something, okay, that connect with another thing, okay, this point and this point, and you have line connecting them with each other, we call this kind of circuit series circuit, okay? So what about parallel circuits, okay? So parallel circuits is, as you may remember, or you have studied before in math, that parallel is something you have two lines are parallel to each other. So what do you mean by that, okay? You have here this, those are two points, and I can just connect them in this way, either by using this line or by using that line. Okay, so when I say that, okay, I can say that those two lines are parallel to each other, means they are connecting the same points in the same time. Okay, so this is what we mean by parallel. Okay, so now we understand the difference. Okay, in the series circuit you have line. Okay, this line, okay, is connecting two points, okay, in the same time. Okay, so you have line, okay, connecting two points in the same time. Parallel circuit, you have two lines connecting the same points. So you still have the same points, but instead of just having one line, you have two lines. Okay, so the two lines here are indication, or they are indicating that we have a parallel circuit. Okay, so now we understand what is what we mean by that. Okay, we call the series circuit, okay, we call the series circuit as end by end circuit. What we mean by that? Okay, we are going to talk about that in much more detail. Okay, so now we are going to talk about series circuit only. Okay, so when we talk about series circuit, okay, think about this. Okay, the components are connected end to end. What do we mean by end to end? Okay, means the end of this point here, okay, will be the start of the other point. Means when you are, for example, you are here, this is the end. Okay, it is related to the other end, the other side. Okay, so means this is end by end. Okay, so one end is connected to one source of light, and the other end is connected to the other source of light. Okay, so if I have those two things are source of lights, and this also source of light, I will call this, for example, this L1 and this L2. Okay, so the line connected them. Okay, it's connected end to end, means the end of the first source is connected to the end of the second source. Okay, so and I have only one line that can connect them. Okay, so series circuit is a very effective in some way. Okay, we are going now to study like the when we can use this. Okay, but what what we can conclude from that? Okay, so the first thing we can understand or um, um, sum up from this kind of figure here, that the current, the electric current is fixed. Okay, so means when you allow electric current to move through this line here, through this wire, okay, the electric current will be constant along the circuit. Okay, so means the electric current is not going to change. Okay, so this bring a good idea about what what we mean by that. Okay, so means the electric current will be fixed along the circuit itself. Nothing will not will change to the electric current. Okay, so resistance will be different. Okay, so but just keep in mind that the electric current, okay, the electric current moving through this circuit will be fixed. Nothing will happen to the electric current. So the electric current will be only fixed value. Okay, why? Because the same current coming through this source is the same current going through this source. Okay, so I have only one current that connect all over the circuit. Okay, and this current is not going to change. Okay, so what is the function of the of why we are using electric series circuit? Okay, so we are using series circuit because we want our current to be fixed. Okay, suppose you want that a certain amount of current that is allowed to come inside your system. Okay, because you don't want much more current to come to through your circuit, So you want to keep the current at certain value. So what you are going to do, you are going to connect the circuit, okay, or design your circuit in series. Why that? Because you want to keep the value of the current at certain value, okay? So we didn't talk about the resistance because the resistance will be a complete different idea, okay? The resistance will be different from one place to another, okay? But just think about this, the benefit of using series circuit or series connection inside the circuit is to bring current into the same and fixed value all over the circuit, okay? So this is the function of the um, series connection inside the circuit, and this is how we can use it, okay? So remember that, okay? The current is fixed, okay? Nothing will happen to the current, okay? The current will keep the same kind of value, okay? And the only kind of difference will happen to the value of the resistance, okay? Because the resistance will be different from one place to another. For example, the resistance at this point will be completely different from the resistance at this point, okay? Because think about that, okay? Here you didn't move through any kind of any kind of electric light, or you didn't use any source of light, okay, to connect. So now, but after that you are going to be connected. After that you are going to move through this path, means you are going to use electric resistance. So you can just imagine this, the value at, I will consider this R1 and this R2, okay, and the value, the difference between R1 and R2 is very, very big, okay? So there's a difference between the resistance and at this point and the resistance at that point, at that point. And this indication that the resistance is not equal inside the series circuit, okay? So this is the difference that you have to just in the beginning try to understand, okay? So keep in your mind that the components in the series circuits are connected end to end, okay? Means one after another, means you, when you are going to finish the first one, you are going to be connected to the second one, okay? And they make the sim like the loop is very, very simple. You don't want to use you don't want to use many wires. You don't want to use many electric devices. So you are just using a small kind of devices, okay? And this is something else you have to understand about that, about this kind of circuit, okay? So when we are using series circuit, we are using this to just connect a small kind of devices, okay? So suppose you have 2 or 3 kind of devices in your home, okay? What kind of connection that you are going to make between them, okay? Are you going to connect them in series or parallel? No, series is very, very effective when you have a small kind or a small number of devices, okay? But when you're not, the number of devices is going up, okay? So at this moment you will start to change your mind. You don't want to use much more current. You don't want to just because some electric devices can use more current, okay, more electric volt, okay. Other, okay, can use a small current and small electric volt. So why I have just to use the same amount of current for different devices? In fact, some devices can be broken or can be destroyed by the high value of the current, okay? So you want to connect them in series, okay? So, and this is the function that we are going to discuss later, but just keep in your mind that we are using electric circuit in series when we have a small number of devices, okay? So this is the function of the electric circuit or the series kind of connection in the electric circuit, okay? So now we are going to talk about the second part, okay, which is the connection of the electric circuit in parallel, okay? So as you can see here, okay, as I told you, okay, we call this parallel because you have here, okay, This line, okay, this line here is parallel to this line. So we call this parallel circuit because we have two lines that are from the point of view of geometry or geometrically they are parallel to each other. So why we call them parallel? Because they are actually geometrically they are parallel to each other. Okay, and we call them side by side. What do we mean by side by side? Means here this is the first side, okay, and here this is the second side. Remember in the begin in the series circuit we were talking about end by end, means when you are ending some the first you are going to end the second one in the same way, okay, but here you are connecting them side by side, means this side, okay, and this side, okay, so they are connecting, okay, and this side is connected with this side, okay, so every two sides are connected with each other, okay, so for this reason we call them side by side, okay. So the current has a choice of routes, okay, or paths, okay. So means suppose here, okay, the current is coming through this point, okay, and this is our eye, this is the electric current, okay, and the current will move through this direction, okay. So what will happen? What will happen to the electric current? The electric current has two choices, okay. Either the electric current is going to move in this direction, okay, and or the electric current is going to move in this direction and complete in this with this electric source, okay. So electric device, okay. So the electric current in this point, okay, will be different from this position, from this position. So means the electric current, if I will call this I1 and this I2, I1 doesn't or can't be equal to I2, okay. So means they are completely different, okay. So means the amount of current going through the first path, okay, so first route or first path is completely different from the amount of current going through the second path, okay. So this is the difference. This is what we call, remember when we were talking about the series connection, we were saying that the electric current is equal, okay? The value of electric current will be equal all over the electric circuit, okay? Nothing will happen to the electric current. But now we are keep this in our mind that as a very, very important difference between the kind of parallel and series connection, that in the parallel connection, the value of electric current will not be equal by any way, okay? Because the current before it goes through any kind of paths, okay, it has two options, okay. Either it's going to move through this direction or it's going to move through that direction, okay. And each one of them is completely different, okay. So they can't be equal, okay. So there must be a difference between the kind of electric current moving through the first path or first route, or the kind of the electric current moving through the second route, okay. So this is the kind of difference between what we are talking about, the value of the current. So remember also, this is one of the first and the most important differences between the electric and the parallel current, okay, sorry, the series and parallel current, that in series, okay, the value of current is fixed all over the system, okay, but in parallel current circuit, okay, the value of the electric current is not fixed, okay, it will differ from one point to another, okay. So suppose here, just to understand the difference, okay, suppose you have here the source of light here is consuming more energy, more electric volt, okay, more voltage, okay, than this system, okay. Suppose you have here, for example, a very, very small device that is not going to consume a lot of energy, okay. And for example, here, you have here, I will just try to help you to think about that. You have here, this is air conditioning, okay. And here you have electric charger, okay, mobile charger, okay. So what do you expect? Which one of them to has to have the highest value of the current? The air conditioner, because air conditioner is consuming a lot of current, so it has to provide, we have to provide this air conditioner with much more current, okay. And the electric charger is not consuming much more or more current like the air conditioner, so we are not going to give or to provide the electric charger with the same amount of current that required to the air conditioner. So this is the difference between the series and parallel, okay? And they are connected by what? By parallel, okay? So I can't connect them in series. Why? Because if you are going to connect those two kind of devices in series, okay, what will happen to the circuit? The circuit, okay, either the air conditioner is not going to work, okay, or the electric charger is going to be destroyed. Why it will be destroyed? Because think about this: you are providing this kind of device with much more current that it's already designed to accept, okay, or to deal with, okay. So in this way, I told you in the beginning that sometimes you have to connect the circuit in parallel, okay? Because the parallel way of connection in the circuit is the best when you have different kind of devices that consuming different kind of current, okay? So this is the benefit, or this is the beneficial side of parallel connection, and this is why we are using parallel circuit, especially in our homes, okay? Especially in a very big places that you have many devices connected with each other. So you want to save the amount of current, and you want to save your device also, okay? So because as I told you, if you are going to allow a much more current to go through the circuit, so the circuit will be, or some electric devices will be destroyed, or will be broken, because actually you are exceeding the value, okay, that of current that they are designed to receive, okay. So this is the difference between parallel and series circuit, okay. And the other thing you have just to keep in your mind that the value of the current, okay. So we were talking in the series circuit that the value of current is fixed, okay. So nothing will happen to the electric current. The electric current will be the same, okay. Only the resistance will be different from one point to another, okay. And when we started to talk about the parallel, we said that this is not going to happen again here in the parallel circuit, because in the parallel circuit, the value of the electric current will be, the value of the electric current will not be the same, okay. So the resistance is the same, but the value of electric current is not the same, okay. So here, this is kind of like, this is a series, again, this is series circuit, okay. This is, you can see here, you have only one source of light, okay. Even here, you have two sources of light, or two sources of the two lamps, okay. So they are connected in parallel, okay. And here, the same kind of lamps, okay, connected in parallel, okay. So this is the difference between what we mean by connection, okay. So you can imagine that, okay, the value of light, okay, the value of light here, okay. I will ask you a very interesting question now, and I hope if you have any, if you can just participate with me and just try to guess what will be the value of the, like, do you think the value of the, or the intensity of the light, okay, the intensity of the light, I will call this, for example, this is one source, this is lamp one, this is lamp two, okay. And what do you expect? They will have one will be equal to 2 in the intensity of the light, or one will be must be bigger or lower than 2, okay? Because depending on certain factors, we can determine which one of them will be higher, okay? So, but first of all, do you think they are going to be equal to each other or not equal to each other? So I hope you can tell me if you have any idea about that, okay? Yes, Rawan?
I think that they are not equal to each other and two will be better than one.
Very good. 2 will be, let's see now. Okay, you said 2 will be equal to 1,
No, no.
or 1,
Two should
yeah,
two should be better than one.
better than 1. Why?
I
It-
don't know.
Okay, okay. First of all, thank you, Ron, because your answer is very, very correct, okay? But just, we need just to discuss which one of them will be higher. For example, suppose you have here, this is the current, this is the value of the current, okay? So here, this is the value of the current, okay? This is I, this is the original current, okay? And you can see that, you can predict that if you have here, this is I1, and this is I2, okay? That I1 plus I2 will be equal to I bigger, okay, or the capital I. Why? Because the value of the current moving through the first route is equal to the value of the current moving through the second route, okay? So the summation of the two values together will give me the total amount of current going through the circuit, okay? So this is first of all, okay? So means I is bigger than each one of them, and it's equal to the summation of each one of them, of each of them, okay? So now, just let us talk about which one of them will be higher, okay? So do you expect this will be higher or that to be higher, okay? So imagine you are dividing two things, okay? What you are going to do, like here, okay? When you are going to divide your current into two parts, okay? You are going to give the first one the highest amount of current, or the second one the highest amount of current, okay? So it's a little bit easier to discuss. It's a little bit easier to determine that the value in I1 will be bigger than the value in I2, okay? So means the intensity of the light in I1 will be equal to the intensity of the light in I2, okay? Because when you are going to divide your current, okay, you are not going to divide this current in equal, okay? Unless you already know that the value or the intensity of the, or the value of the sources, or the amount of electric field in the sources is equal in the two sides, okay? But just if you don't know this, you are not going to divide them in equal way, okay? So you are not going to do this. So you are going to design one of them to receive much more current than the other, okay? And this is what we are talking about. So means the intensity of the light at this part will be higher than the intensity of the light at that part, okay? By the way, you can design your circuit to do the opposite, okay? But we are just trying to imagine that we have a very, very um, normal system that can divide the electric current in normal way, okay? But you can do the opposite, okay? You can just try to make this electric source bigger in the current than the other source, okay? So it doesn't matter, okay? But just the idea is just to keep in your mind that just try to compare between the electric current here, okay? If you have, for example, here we have two electric sources connected in series, okay? And we have two electric sources connected in parallel, okay? So you can see here that the electric or the intensity of the light here is bigger than the intensity of light here, okay? Because the value of the current here will be bigger than the value of the current in the parallel circuit, okay? So this is just a difference between the intensity in the two sides, okay? The intensity in the two sides, okay? So just a clear idea about what we mean by electric current division inside the circuit, okay? So when you are going to divide the electric current, the value of electric current itself is going to be decreased, okay? So means the intensity of the light is going to decrease because we remember that, okay? We say that the electric current is the movement of free electrons from one point to another, okay? So if you don't have the free electrons that can freely move from one point to another, the value of the current is going to decrease, okay? So this is something that you have to keep in your mind that from the point of view of comparison between the kind of connection in the series and electric and sorry, in parallel circuit, okay? I can see now some of you have some questions, okay? So Ahmed Omar, Ahmed Omar, who's, does anybody has questions here? Okay, you don't have any questions about that? Safe? Yes, safe.
Mr. I didn't understand the last point you explained.
Okay, safe. Safe, we were comparing between the source, the connection here, and the connection in this circuit, okay? We have two circuits, okay? One of them is connected in parallel, and the other is connected in series, okay? And we started to compare between the value of the current in each one of them, okay? First, we started to say that the value of the current when we are talking about the kind of parallel circuit, okay? We started to say that, okay, the value of the current here, if I will call this I1, is not going to be equal to the value of current here, I2, okay? So means I1 is not equal to I2, okay? Because, and both of them are not equal to I total, okay? Because the current itself is going to be divided into two paths of two routes, okay? And the electric current is going to be halved or maybe divided, okay? So I don't know if this would be equal to I1 is equal to I2, maybe I1 is equal to I2, which is equal to I total, but means what we are talking about is the electric current, the value of electric current is not going to be equal in the two sides, okay? So this is the first thing, okay? We said that electric current here I is equal all over the circuit, okay? So nothing will happen. So the intensity of this source will be equal to the intensity of this source, okay? Because they are connected in series, okay? And the series kind of connection is keeping the value of current fixed, okay? So nothing will happen to the value of the current, okay? So what will happen in the other direction, that you have electric current that has been decreased, okay, because you are connecting the circuit in parallel. So means the value of I1 maybe equal, maybe not equal to I2, okay, but in most cases is not equal to, okay, and both of them are not equal to I total, okay, which is the original current coming from the source, okay. So means I is equal to I1 I2. So how can we translate this into um, in the parallel circuit? Okay, that the value or the intensity of the light in this source will be lower than the value of the current or the intensity of the light in this source. Okay, so means as you are going to move into parallel circuit, the value of the current is going to decrease, and the intensity of the the light also is going to decrease. Okay, so this is what we were comparing between the intensity of the light, okay, in the parallel and in the series circuit. Okay, so this was what we were discussing before. Okay, so do you have any questions? Because if you don't have any questions, I'm going to show you. Okay, Mariam. Mariam.
Good morning.
Good morning, Mariam.
I have a question.
Okay.
How do we measure the current flow?
Okay, so you remember, Mariam, we said that the value of the current at any point, okay, at any point, at any wire, okay, it can be measured by the flow of electrons. So how many electrons are moving through this wire, this line, this, for example, I will take this point or this, or this is a very, very interesting questions because many people are just trying to, you know, how can you measure something very, very small? Okay, electrons can't be even seen by our eyes. Sorry, by even the microscopes. Okay, we can't even try to imagine the value or the shape of the electrons with our eyes. Okay, so imagine you have this point here, Mariam. Okay. I will just consider this. I want to measure the value of the current at this point, okay? So what I'm going to do, I'm going to measure certain things, okay? How many electrons are flowing through this point, okay? And at how many time, okay? For example, at how many seconds, okay? For example, I need 30 million electrons in 1 second, okay? So this is the value of the current. So means at each point you have 30 million of electrons moving through in 1 second. Okay, so for every point like that, okay, for every point, okay, and imagine that you have 30 million of electrons. Okay, I just try to measure, take a very, very big number because the flow of electrons is very, very big. Okay, so we are using just something very, very super massive just to imagine, just to let you imagine the value of the current, okay, or the value of electron moving through 1 point. Okay, so here you have what you have, 3 million electrons moving in 1 second. So this is the value of the current. Okay, so what you have in electrons, okay, what electrons you have, okay, at certain point, okay, at this point here, at 1 second or at 1 minute, okay, or at 1 hour, okay. So how many electrons are flowing through your system, through your wire, okay, and at certain time, because we are measuring the flow of current at certain time. Why that? Okay, because if you are going to consider this in random way, electrons can flow in some minutes more than others. Okay, so I want